Okay, so today we're going to cover the middle part of the notes. We're actually going to break this 21 slides here into 3 different days. I'm going to do the middle portion. We already learned how to graph them. We learned about E. It's sort of like pi. Its approximation is 2.71. We learned about the shifts for the exponent graphs. We actually did some shifts. And we're going to learn the one-to-one property. This is also, you might have heard it as we're doing the change of base. So again, for a greater than 0 and a not equal to 1, if a to the x is equal to a to the y, if and only if the exponents x and y are equal. So what we're going to be doing here is we're going to be trying to change the larger base to a power of the smaller base. Sometimes we have to change both bases, but our goal is to make both of the bases have the same number. One thing to remember, that anything that is raised to the power of 0 equals 1. The other thing, so here's the type of questions you're going to see. Let me come down here at the bottom. So you'll see, you're going to be given something like this where the variable is going to be the exponent. So for example, if I say, find out what x is when 2 to the x power equals 8. Now, a lot of you can probably look at this and say, oh, I know 2 to the third power is 8. But what our goal here is going to be is to change the bigger number, the 8, into a base of 2. So what I do here is I'm going to keep this one, and I'm going to change the larger number so it has the same base as the smaller one. And I can change 8 or transform 8 and make it 2 to the third power. Once the bases are the same, get rid of the 2's, the base, that are identical, and then you set the 2 exponents equal to each other. And that's your answer. So again, remember anything to the 0 power is 1. Also remember when you have a negative exponent, for example, 2 to the negative 1, this means 1/2. You put the 2 underneath a 1. Also remember when you have a fraction exponent, this is really saying find the square root of 4, and it's 2. So just remember, fraction exponents are going to become radicals, square roots, cube roots, depending on the exponent. And then negative exponents turn it into a fraction. So let's just try some examples. So again, we're going to use the one-to-one property, and we're going to try to make the bigger number have the same base as the smaller number. So if I zoom in here, I'm going to try to make the bigger number, which is 9, have the same base as the 3. So I'm going to try to change 9, so it's a base of 3. And I know that 3 squared is equal to 9, so I'm going to change the 9 into a 3 squared. Then this side I leave alone. It's 3 to the x plus 1 power. Now that I have identical bases here, I can get rid of the base, and now I'm going to solve the equation that remains. I am going to set 2 equal to x plus 1. I'm going to solve for x by subtracting 1. 2 minus 1 is 1, and x equals 1. Now, whenever you're doing any of these problems, remember you could check your answer. I can take what I just found x to be equal to and plug it in up here. So if I take 9 equals, and then take out the x and put 1 plus 1, 1 plus 1 is 2, 3 squared is 9, it works out, I did it correctly. So my x equals 1. Now we have a fraction. So again, on this one, we're going to change both. I'm not going to try to make 8 into 1/2. What'll be easier for me is to change the 1/2 into 2 to the negative 1. because 2 to the negative 1 power equals 1/2. I'm going to write the x that's still there, and then I'm also going to change 8 into 2 to the 3rd power. Now that I have the same base, get rid of the 2's. We're going to use our exponent rules. Remember, when you have a power raised to a power, we multiply here. So negative 1 times x is negative 1x equals 3. I need to solve for x, so I need to divide both sides by negative 1, and x equals negative 3. Again, let's test it out. If I go back up and plug in negative 3 over here on the 1/2, remember, whenever you have a fraction raised to a negative exponent, think reciprocal. Flip it, make it positive. I can simplify 2 over 1, make it 2. 2 to the 3rd power equals 8, and that's what I wanted it to equal. So again, whenever you get whatever x equals, you can plug it back in. Now, when you take the test for this, you're going to have a calculator portion and a non-calculator portion. So you would not be using a calculator for this portion. However, the last part, the last couple slides of the notes where we're doing the interest equations and we're using E, that's when we're going to use our calculator. But this part of the test would be no calculator. So you're going to have to do all this by hand. Let's try 17. So again, I'm going to try to make the 8 into the smaller number. I can change 8 into 2 to the 3rd. And now 2 is raised to the 2x minus 1. I have the same base, get rid of it, and now set the exponents equal to each other. 2x minus 1, going to add 1. 4 equals 2x. Divide by 2, and x equals 2. Again, you can plug it in, and it should give you 8 once you plug it in there. Now, this is all we're going to do is just a bunch of examples. Now, what might be very helpful is if you memorize some of these common exponent equivalents. So, for example, you should already know, for example, that 2 squared is 4, 2 to the 3rd is 8, maybe even memorize 2 to the 4th is 16. You might also memorize that 3 squared is 9, 3 to the 3rd is 27, 4 squared 16, 4 to the 3rd 64, and so on. So memorize some of these because when you see the numbers, it might help you to recognize what do I need to make it into. Again, if you have a 1/3, know that you're going to change this into 3 to the negative 1. Or if it was 1/9, it would become 3 to the negative 2. So when you see fraction, think negative exponent. So let's try the next one. Yes. So again, my goal here is to make them have the same base. Instead of trying to make 27 into a 1/3, let's make them both have a base of 3. So again, the 1/3, I can change this so it's 3 to the negative 1. But remember, it still has this negative x exponent that's there. And then the 27, I'm going to make this 3 to the 3rd. So again, that would be its power. So now the bases are the same. Get rid of the 3's. Again, remember, we need to multiply this power to the power. Negative 1 times negative x is going to give you positive x. So really what's happening here is negative 1 times negative x equals 3. Negative times negative makes it positive 3. And again, you could have plugged it in. Take the 1/3 raised to the negative x, put in the 3 here, And again, it's 1/3 raised to the -3. Think reciprocal. When you see negative, make it positive, and now evaluate it, and it does give you 27. The next one, same thing. I'm gonna go ahead and turn the 1/3 into 3 to the -1. It's still raised to that x power. And then I'm going to change the 81, and this becomes 3 to the 4th power. Multiply the power to the power. This becomes a -1x. If you want to put the -1, you can. You don't need to. Divide by -1, and that exponent is a -4. Try number 20. Again, I'm going to do a change of base here. I'm going to make the 8 a base of 2. So this stays the same. It's going to be to the x plus 4 power. I'm going to change the 8 into a 2. Now, it's a 2 to the 3rd. And then this x minus 6 is still there. I now need to multiply this power to the power. So the bases get canceled. I'm left with x plus 4 equals 3 times x minus 6. I'm going to distribute. Becomes 3x minus 18. I need to get my x's together and get my constants together. Doesn't matter which way you move it. So I could move the x to the other side. Let me do this in a darker color. It's canceled from here. I get 4 equals 2x minus 18. Add 18. 22 equals 2x. Divide by 2. And x equals 11. Again, you could plug it back in for both x's in the original, and if it doesn't simplify to the same answer on both sides, then you've done something wrong. So again, just be careful. So again, I need to do a change of base. I'm going to make 8 2 to the 3rd. So this one stays the same. The 8 becomes 2 to the 3rd. Get rid of the 2 and solve what remains. 3 minus x equals 3. I'm going to subtract 3 from both sides. Negative x equals 0. Now, don't get confused here. You're dividing by -1 technically, but 0 divided by anything is 0. So let's try to check this one. So if I take 3 to the 3 minus x, and I plug in a 0 here for this x, then I get 2 to the 3rd, which equals 8. So it works. So just be careful. All right, now we actually have a different number. Now we have 5. But again, 5 squared should be something that you should know is 25. So I'm going to change the 25 into a 5 squared, because that's equivalent. Now that I have the same bases, get rid of the 5s and solve what's left for the exponents. So I'm left with 2x plus 1 equals 2. Going to subtract 1. 2x equals 1. Divide by 2. And x equals 1/2. Again, you can plug it in and make sure that it works. Now, don't panic when you see the next one and say, wait a minute, whoa, I got an e here. We're still just making them the same base. And the base is e. So all I have to do is cross off the e's and solve the exponents that are left. Remember, this power to the power, you multiply it. So I'm going to just be solving 4x minus 1 equals 2x. Remember, e is just a number. So in this case, I need to get my x's together. So I need a minus 4x, no constants to group. Divide both sides by -2. Negative divided by a negative makes this become positive 1/2 equals x. And again, you can plug it back in and just make sure that those powers end up being the same thing. But again, don't panic when you see an e. We're just still doing the same thing, making them have the same base. We have 6 more examples, and then we're done. Okay, so again, I want to do a change of base here. So I need to make them have the same number. Again, I know that 3 to the 3rd power is 27, and 3 squared is 9. So I'm going to make them both have a base of 3. So I'm going to change the 27 into 3 to the 3rd. But remember, the 4x, the power that was on the 27 is still there. I'm going to do the same thing for the 9. I'm going to make this a 3 squared. And it still has the x plus 1 power up top there. Now again, we have to multiply these power to the powers. So I'm going to multiply 3 times 4x. This gives me 12x. And then over here, I have to distribute the 2 to both the x and the 1. So this will become 2x plus 2. And now I need to solve for x. I'll subtract 2x from both sides. I get 10x equals 2. Divide by 10. X equals 2/10. I need to reduce it, and it's 1/5. So if you're good at recognizing what you can change the numbers into, it makes these a little bit easier. So again, definitely memorize 2 to the 2nd, 2 to the 3rd, maybe 2 to the 4th. Same thing for the 3, 4, and 5. Chances are I'm not going to give you something with a huge base that you're going to have to switch it to. But 2, 3, 4, and 5, all easy enough numbers. So again, let's try the next one. Again, I'm going to change that 4, so it's a base 2. I know that 2 squared is 4, so I'm going to change the 4 into a 2 squared. Remember, it still has its original exponent here. And then this side was still just staying the same. Let me go ahead and do the exponent in green so you can see. Again, I need to multiply the power to the power here, but the 2's are gone. So then over here it becomes 2 times x minus 2 equals 3x plus 3. I need to distribute 2x minus 4. Now, just to show you, I know the other time I moved my variables to the right so it stayed positive. I'm going to move the 3x to the left. It doesn't matter. Your goal is just to get your letters on one side of the equal sign and your constants on the other. So then this gives me a negative 1x minus 4 equals 3. Add 4. Negative 1x equals 7. I can't have a negative 1x, so I divide by negative 1, and x equals negative 7. Here we go again with the e, but again, don't panic. Now, this should have been side by side. So let me just rewrite this. So 1 over e equals 1 over e squared to the x plus 1. So the first thing I'm going to do is make them have the same base. I'm going to actually change 1 over e and make it e to the negative 1. Get it out of that fraction. And then it's left with the negative x that was there to begin with. Let me do this in a different color because it's not showing up as much on the white. Okay, and then over here, I'm going to do the same thing, but it's going to be e to the negative 2 power. And then it still had the x plus 1 up here. So again, it has the same base. Get rid of the e, but multiply this power to the power. So it's negative 1 times negative x equals negative 2 times x plus 1. Negative 1 times negative x is positive x. Distribute the negative 2. And now I need to combine and get my like terms together. So add 2x. 3x equals negative 2. Divide by 3. And that power is negative 2/3. Again, remember, e is just a number, approximately 2.71. All right, we have 3 examples left, and then you can get started on your homework and ask me any questions as well. Now, these are similar. Some of these are going to be similar to what we did at the beginning, like the last example. But let's go ahead, and we've actually got now one where we're going to make it into a fraction exponent because we've got a square root here. I'm going to make them both have a base of 2. I'm going to change the square root of 2 and make it 2 to the 1/2 power. And it still has the power up here, the x plus 4. I'm also going to change 4 and make it 2 squared. Now that it has the same base, get rid of the 2's, but multiply the power to the power. So here I'm going to get 1/2 times x plus 4 equals 2 times x. I can go ahead and distribute. Now, you can work with this as a fraction if you choose. I'm going to clear the fraction. I'm going to multiply everything by 2. But if you'd rather subtract the half and get 1.5x, you can do that. But what I'm going to do is multiply everything by 2 to clear the fraction. So when I distribute it here, this just becomes an x. When I distribute it here, it becomes a 4. And when I distribute it here, it becomes a 4x. I'm going to get my like terms together. 4 equals 3x. Divide by 3, and x equals 4 over 3. Now again, if you would have rather done this, left it the fraction, subtract the half, then this would have become, I can make this a common denominator, make this a 4 over 2x, and then I get 2 equals, did I write the right thing? No, I wrote the right thing. And then put 4 over 2x, then 3. 4 minus 1 is 3, not 4. I would have gotten 3 over 2. And then what you're going to have to do is divide both sides by 3 over 2, which really means multiply by the reciprocal. And then this becomes 4 over 3 equals x. Same answer if you didn't want to clear the fraction. Doesn't matter. Now this next one, instead of doing a change of base, because I've got a variable here as the base, not the exponent, what I'm going to do instead is I'm going to keep the 1 over 27. I'm going to turn b to the negative 3 into what it means, b to the 3rd. And then now I'm going to solve this as if it's a proportion. So what I can do here is multiply diagonally. And I get b to the third is equal to 27. And now I can square root both sides. Is that showing up? No. Cube root both sides, sorry. To cancel the cube. And then b is equal to 3. Now, if this were a square root and we were solving for it, we would put plus minus. But because it's a cube root, I only leave the answer that it is. So b equals 3. Same thing on the last one. We're going to do like we did at the beginning of the year. Again, our variable is not the exponent on these. It was the base. So here what we need to do is, in order to fix this, we're going to raise both sides to the reciprocal power. So let me go ahead and rewrite this here. So I'm going to raise both sides to the 3/2 power. This would simplify. This all becomes a 1. So I'm just left with r here. And then what I'm going to do here is I can do two things. I can either do the exponent first. So remember, when it's a fraction, this 3/2, the top is the exponent and the bottom is the root. Now, keep in mind, I can either choose to do 4 to the third first and then square root that answer. And then this gives me plus and minus 8 equals r. Or I could also have done square rooted it first. So I could have done the square root of 4 and then cubed the answer. So once I square root it, I would have gotten plus and minus 2 and then cube it, and I still get plus and minus 8. So just keep in mind, you can choose whether you want to do the exponent first or if you want to do the root first. Now, let me add a problem to this. Let's say it was 64 equals x to the 2/3. On a problem like this, once I multiply both sides by the reciprocal power, I wouldn't want to do 64 to the 3rd power without a calculator. I would rather square root it first and then cube that answer. So for example, if I square root 64 first and then cube that answer, that'll be more reasonable. This would give me plus and minus 8, and then I cube that. It's still big, because I got to do 8 times 8 is 64, times 8 again, and it's 512. So if you can square root it first, do that, and then do the exponent second. Let's say we had something that wasn't a perfect square. I know these aren't in the notes, but I just want to add one more. Let's say it was 8 raised to the, or this. So again, the other two were perfect squares. So in this case, again, I'm still multiplying it or raising it to the reciprocal power. So here, if I were to do the square root first, the square root of 8 becomes 2 times 4, and then 2 and 2. And in simplest radical form, this becomes 2 square root 2. So plus and minus 2 square root 2 equals x, but then I've got to raise that to the 3rd power. So really what this is like is doing 2 square root 2, 2 square root 2, 2 square root 2. 2 times 2 times 2 is 8. And then this becomes 2 times 2 times 2. This actually becomes 8 as well, but then you got to go back and break it down. And then this becomes 2 times 4. And again, the square root of 8 is 2 square root 2, but you still have the 8 out front. So then this final answer is 16 square root 2. So this was more of what we did at the beginning of the year. when we were solving for the base. Most of your homework tonight is the variable will be the exponent. So again, just remember that when it's 2 to the 0 power, it's 1. If it's 2 to the negative 1, that means put it under a 1. If it's 2 raised to the 1/2 power, again, this would have been the square root of 2, which would have been a non-perfect square. So that is it for the middle part of the notes. Again, your homework is 5.1b. You have a few WebAssign problems, but then when you click on the assignment, there's also a PDF. So complete both and just turn in one document. So you can get started, and then what I'll do is tomorrow after 8 o'clock, I will post the solution file for the PDF, and then that way you can check your answers. And then any questions you have, you can ask me tomorrow in class. And then tomorrow we're going to learn the 2 interest formulas. We'll do a few examples. And then I'll also answer any questions you have for Wednesday's quiz, or if you need help with your calculator. We do have a little bit less than 15 minutes. So if you do need help with your calculator, I can help you with that. Or if you have any homework questions, I can help you on that. Everybody good? Any questions? So this was 5.1b.